Good. Hello, Pak Adit and friends. Today I'm going to present my case on of optimization of production process. This article is in so the abstract is this article is intended to introduce the reader to the basic ways of increasing the efficiency of current production when problems arise from inaccurate planning of production. The article is based on a study that is gradually implemented as system measures in actual production. Simple and logical improvements bring efficiency improvements and production deadlines. The method used are suitable for both production and logistics. The study is for a medium-sized company, but the authors want to extend it to small businesses. Small businesses do not fully perceive this area, nor do they accept problems in this area. As part of consultation and inspection, we find that small businesses have significant systematic shortcomings, but owners do not admit this. First of all, the introduction. The main purpose of this study is to approximate shop floor layout optimization and define time consumption standards in order to ensure timeliness deliveries to customers and improving quality. This case study was processed in the company that is engaged in development and production of composite and sandwich materials for a wide range of application in the transport industry sector. The company specializes in demanding application and specialty products where the need for light and solid materials is very important. The company is engaged in project and serial production. This means production in small series on the demand of customer needs, assembly line in production in large series. And then the production layout optimization. When solving the shop floor arrangement, we proceed by first analyzing the current state of workplace layout and production processes, and then creating a model of the current state with material flows. There may be more suggestions for workplace optimization, and therefore we evaluate proposals for variation in spatial layout. The main purpose of the layout analysis is to identify the current bottlenecks of the manufacturing system and find effective measures that eliminate them. And then the default state analysis. The original layout of the workplace was very unsatisfactory at first sight. There was a disorder in the workplace. The working tools had no fixed place, and workplace was unsatisfactory in terms of work safety. Workers spent much of the day looking for something, and there was not enough space to work. A big problem was the storage of molds and handling them in the round of industrial furnace. The industrial furnace has a limit capacity and has become a bottleneck, causing the products and semi-finished products accumulation around. The furnace molds are left all around the workplace after being pulled out of the oven according to currently empty space. There were also elements in the layout that had to be kept. These elements included the above mentioned furnace and space for other production. So this is the original layout of the workplace. And then the proposed layout. Microsoft Visual was used to propose a new layout for the workplace. The whole workplace was measured before the proposal, so the real scale was considered when working on the proposals. Also, the necessary workbenches, molds, shelves, etc., were measured. The area of the entire intended workplace is 400 meters square. The new layout proposal was differed from the original as follows. Unnecessary workbenches have been removed throughout the workplace, where we found out that they are used in most cases only to postpone things that are no longer intended. Fixed place for storing molds that were previously freely stored in the workshop was defined. This place will then be standardized. There has been a general arrangement of workbenches. Some workbenches, especially single purpose, were replaced with multi-purpose new ones. The unnecessary shelves have been removed from the workplace. If possible, the needed shelves were replaced by wall-mounted shelves. The passage of escape routes and the availability of fire extinguisher have been ensured. The free space on the walls have been used as a storage for material for production by means of suspension racks. And then this is the figure number 2, the new layout design. Time consumption optimization. Second part of optimization the production processes was time consumption optimization. At this stage, work measurement time study was unnecessary to analyze time consumption and comparing measured times to manufacturing times proposed by firm technologies. Time study result. Every worker involved in production process of production of products needed for the study was measured. The products were observed, were semi-familiar with the measurement in advance, but they were not told which employees was observed on particular day. Um, some of basic some of basic steps of work measure time study was followed. We used the basic working aids, stationary form and stopwatch before the actual measurement. The general activities performed by the workers was described was was described and analyzed. Measurements started at the beginning of the shift and the stopwatch ran for the entire shift. Any activity performed by workers any activities were performed by workers during their shift has been recorded into the form along with the measured time. After mapping over activities, the paper form of the data was transferred to the a computerized form using tables in Microsoft Office Excel. From the tables, the corresponding graph were created. Time study result. During the observation, an average of 50 activities were recorded for each workers. It should be noted that the activities were performed on the same or familiar or similar parts. Since the activities were often repeated, they were reduced to individual groups. For the purposes of this work, the time studies of 4 female workers were used. Their work operations differed only minimally, so the results of the studies could be compared and evaluated. Work activities were divided into 7 employee activities. And then summary of the research. Optimizing the shop floor layout and defining the time consumption standards was the main focus on this contribution. However, during the analysis and measurement, several shortcomings were observed which decreased work efficiency. For example, the number of workshop hand cart. Each worker should have mobile trolley which can be manipulated as needed. This trolley should be used to buy a to lay down work aids such as a tool case, a hot air gun, or personal belongings. The shortage of these trucks was due to new employees. In order to remedy this, an immediate request was made and these trucks were immediately manufactured. And then another drawback was the butyl pistol. This pistol served for final sealing of the mold. It was found that this pistol is only available to 3 different manufacturing workshops. Therefore, it was constantly borrowed and traced where the pistol is. Of course, this resulted in undesirable downtime in activities. This issue has been resolved by immediate ordering and delivering additional guns to the workplace. There was also a lack of the necessary work aids such as a hot air gun, and each of the workers should have their own and not be looking for and borrowing it somewhere. Again, they were ordered and delivered to the workplace. Modification of manufacturing processes is ongoing and consists in correcting erroneous time consumption standards. So the conclusion to this paper is that to meet the main objective by the end of 2019, production deadline have been raised from 57% to 98%, and the cost of additional work reduced from 30% to 15%. Important steps have already been taken. Direct measurements method were used in the analysis and measurement phase, which consisted of scanning of female workers and individual parts. Furthermore, the layout of the workplace and the data from the measurements were distorted at this stage. Time consumption standards have been set for the improvement phase and a new workplace layout have been proposed. Also, all observed deficiencies were removed. The checking phase is now in the solution, but it assumed that the 5S standards are set up and the audits are carried out. With regard to the current situation in the company, production planning has already been improved, and so far the target fulfillment percentage increases from 57% to 34 to 74% has been fulfilled. Verifying the goal of working to reduce the cost of extra work is currently in solution. Further long-term imaging is still in progress. So far, the achievement of this goal cannot be assessed, but it cannot be considered an error as the study is still running and there are likely to be some adjustments. This research was supported by Support Research Program of Thomas Bata University in Zlin, or RVO. Funding was extended through TBU in Zlin number IGA/FAME/2019/007/increasing business competitiveness by meeting customer requirements in customer relationship management using industrial engineering tools. Thank you. That's all for me today.